Hey, it's Emma here, and this is the first of a few videos on the internet, and here we're going to focus on some of the key components of its structure. In addition to the basic structure, we'll talk about IP addresses, domain name, and how they are linked with DNS. The internet is a worldwide network of networks that follow the TCP/IP protocol stack. It is an interconnected network. We'll focus on that in a few videos. A common misconception I want to clear up early is the difference between the internet and the World Wide Web. The internet is the hardware, and the World Wide Web is simply a service provided on the internet. The World Wide Web consists of linked web pages that are transmitted across the internet and sit on servers. The internet started in the late 60s, the web only in the early 90s. They're not the same thing. The internet infrastructure is effectively maintained by internet service providers, ISPs, which are large organizations providing access to the internet. A few very large Tier 1 internet service providers comprise what is sometimes called the backbone of the internet because they own the transcontinental cables and the very large and powerful routers. There isn't a set list of Tier 1 internet service providers, but Vodafone is sometimes put in this category alongside giants like Verizon. The majority of the internet service providers, however, are said to be below them in the internet's hierarchy, and these are smaller internet service providers which connect to the backbone and are actually provide access to the end users via routers. We'll define routers properly later. Part of the definition of the internet was that it's a network of networks. It's really a giant wide area network made up of smaller WANs, which are the ISP networks, and which connect the vast number of local area networks. IP addresses come from the Internet Protocol and are the unique identifiers devices connected to networks have. A key property we'll learn about is that an IP address can tell you where the device is geographically. Originally, each IP address was 32 bits long, which is 4 bytes. This version is called IP version 4. When you see an IP version 4 address, they are always in 4 blocks of decimal numbers separated by dots. This is called dotted decimal notation. Since we have a byte allocated for each block, they can each range from 0 to 255. Overall, using 32 bits per address, you have a total of 2 to the power of 32 permutations, since you're using base 2 and have 32 numbers to play with. In case you don't know, permutation is the same as combination, except the orders matter. An IP address with the same numbers in a different order is a different IP address. So anyway, using IP version 4, you can have roughly 4.3 billion devices with unique IP addresses at one time. This was exhausted finally in 2011, but fortunately it was foreseen, and the development of IP version 6 started in the 90s. This uses 128 bits, or 16 bytes, which massively increases the permutations. In long form, they're represented with 8 blocks of 4 hexadecimal digits separated by colons, instead of full stops. This leads to a huge 2 to the power of 128 possible unique addresses. Currently, both versions are used, and they are designed to work alongside each other, though IP version 6 will eventually take over. To load a web page, you can type in the IP address of the web server responsible for it. To say this is pretty awkward is to do as an understatement. This actual underlined IP address is for the Google web server, but you'd much rather type in the URL containing the memorable domain name. So a domain name is a name identifying one or more IP addresses. As you can imagine, google.co.uk isn't linked to a single web server. It identifies many, all with different IP addresses, and they constantly switch them up. The system that allows us to connect to a name to an IP address is the DNS, or the Domain Name System. It works as a tree hierarchy of names and abbreviations. At the top, you have the root, which we abbreviate to a full stop. Below, you have top-level domains like UK, com, net, edu, gov, etc. These themselves are subdomains of the root. You can then expand the DNS tree using the domain name back to front. For example, co, which is UK specific and stands for commercial, is a subdomain of the UK. Then Google is a subdomain of that, and then so is www. The definitions got slightly blurry, but www is a host because it refers to the web server hosting Google's web pages. So the full domain of that path on the tree is www.google.co.uk with a full stop on the end, which refers to the root. Normally we omit it though for convenience sake. This is called a fully qualified domain name because it uniquely identifies a host. In this case, the default web server. An FQDN contains a host ID and a network ID. We'll look at what this means when we cover IP addresses in more detail soon. When a user types a domain name into a web browser, the browser acts as a client and requests that a special purpose server called a DNS server, or confusingly sometimes just DNS, translate it into the corresponding IP address. DNS servers form their own network called the Domain Name Server System. If a DNS server doesn't have the IP address of the domain in its database that it has been requested to find, it then acts as the client and requests it from another DNS server until an IP address is returned to the original browser. It requires a lot of organisation to maintain the DNS servers and to ensure no two domain names or public IP addresses are the same. The official organisations that administer this and actually allocate them are called Internet Registries. There are currently 5 regional Internet Registries. Don't worry about memorising their names. I imagine you're sensing a theme now, as these also work in a hierarchical manner. An ISP assigns you an IP address, which they receive from local registries, which belong to these 5, and then those local registries get their allocation from those regional ones. Looking at an IP address, you can see which region the device is, due to whether it sits in a range of one of these registries' allocation. Right, so let's revise what we just covered. The internet is a worldwide network of networks that follow the protocol stack TCP/IP. The web is just a service hosted on the internet. Internet service providers are organizations that provide access to the backbone of the internet. Devices connected to the internet have a unique IP address, which is 32 bits long if it is IP version 4, or 128 if it is version 6. IP version 6 is needed due to there being too many devices for version 4 to uniquely identify. Through the domain name system, we can link a difficult-to-read IP address to a memorable domain name. DNS servers are the dedicated pieces of hardware that translate them. Finally, Internet registries are organizations that oversee and regulate the allocation of domain names and IP addresses. They are needed so that they are kept unique and IP addresses are limited to specific geographical reasons.